In this video, we shall discuss about the intermolecular forces, which are of several types. First of all, these intermolecular forces that exist between one molecule and the other molecule in a given mixture or a solution or a component, the intermolecular forces are generated because of the presence of oppositely charged ions or same charged ions. If we have positive and negative ions, there will be unlike forces between them. That means the unlike forces are nothing but the attractive forces. If there are like charges, like positive and positive ion are there and negative ion are there, the forces of attraction between these like charges are said to be the repulsive forces. Both attractive forces and the repulsive forces come under the intermolecular forces. The very first type that we're going to discuss is the ion-ion forces. That means between the two ions, if the attractive forces exist, they are called ion-ion forces. Let us consider sodium chloride ionic compound crystal, where sodium is the electropositive element and chlorine is the electronegative element. So it's very common that electropositive element loses electrons and becomes positive, and electronegative element gains electron and become negative. So in the sodium chloride crystal, we see sodium ions and chloride ions. So sodium has 8 electrons octet around it by getting a positive charge, and chlorine is also getting an octet configuration by gaining 1 electron from sodium. So between this positive and negatively charged ions, the attractive forces that we see are called ion-ion forces of attraction, or we can also call them as electrostatic forces of attraction because they exist between the 2-point charges. And these are said to be the highest magnitude of interactions that exist between the ions. They have the highest magnitude or higher value. Now the second type of intermolecular forces are ion dipole interactions. Ion dipole forces or interactions. Now what are these ion dipole interactions? As the name indicates, it is between an ion and a dipole. Dipole is nothing but it's a molecule which contains a permanent dipole moment with partial positive and partial negative signs. This ion can be either positive or negative. Now let us look at the salt solution, that is sodium chloride added to the water. Now NaCl is added to the water, we know that we get a salt solution. That means the salt is completely dissolved in the water. Now what actually happens inside the water is Na, Na plus ions are formed and chloride minus ions are formed. Now there is a chance of these Na plus and Cl minus ions combining in the water again to form salt. But in reality it is not happening because the water molecules which are polar in nature, we have H plus and OH minus. This will stop the Na plus and Cl minus to combine. How? This way. Around the Na plus ions, we see OH2 molecules attaching. This way, around the sodium ion, the water molecules get surrounded. This process is called hydration, and the ion which is surrounded by water molecules is called hydrated ion, and the energy released because of this process is called hydration energy. Now around the chloride also we see the water molecules arranging this manner. This is also a hydrated ion. Now the force of attraction that we see between the sodium ion and the water dipole, or between the chloride ion and the water dipole, are called ion dipole forces of attraction. Now the magnitude of this ion dipole forces is said to be equal to Z into mu by R square. That means the value or the magnitude of ion dipole forces is proportional to the Z. What is Z? Z is the charge on the ion. It can be positive or negative. This is said to be Z. Mu is the dipole moment on the molecule. How strong is the dipole moment present in the molecule indicates mu. And R square or R indicates the distance between the ion and the dipole. How far are they? That indicates the distance. So ion dipole forces can be calculated by using this equal to Z into mu by R square. These are mainly seen in the aqueous solutions like NaCl and water. Dipole forces are seen in polar molecules. If we consider HCl, HCl being a polar molecule where we can write H plus and Cl minus because of the difference in the electronegativity between hydrogen and chlorine. These molecules are said to be the polar molecules where we can separate them into positive and negative charges. These experience the dipole-dipole forces. This is because HCl showing positive and negative charge, when it is closely placed with the HCl other polar molecule, we can observe the negative charge of chlorine of first molecule attracting to the positive charge of hydrogen of the other HCl molecule. So this way we can see the dipole-dipole forces. Now the strength of the dipole-dipole forces depends upon the magnitude of the dipole of the molecules. Depends on the magnitude of the dipole of these polar molecules involved. So if the molecules are stationary, they are not rotating, in such case the magnitude is proportional to 1 by r cube. If the molecules are rotating, in such case the magnitude of the dipole forces is inversely proportional to r power 6. We can show the electron cloud of HCl. The single bond that is present between H and chlorine is more directed towards the chlorine because it is polar. Type of intermolecular forces are dipole induced dipole forces. By the name we can infer that the forces of attraction that exist between a dipole molecule or a polar molecule and the non-polar molecule. For example, consider HCl being a polar molecule where we can write it as positive and negative charges, and we have Cl2 molecule where we can write this as positive and negative. In general, when Cl is separately placed, Cl2, both the chlorine atoms are equally electronegative. The electronegativity difference is 0. We cannot write this as positive or negative. But when the Cl2 is placed along with HCl, the negative and positive charges present on the HCl can induce the electron cloud of the Cl2 molecule also and split it into positive and negative poles. So the permanent dipole that is present in the HCl polar molecule induces the dipole of the electrically neutral molecule by deforming its electron cloud into positive and negatively charged ions and develop the attractive forces between them. Such interactions are called dipole induced dipole forces. Now when Cl2 is removed from HCl, it will lose its property. So this dipole induced dipole forces are temporary, that exist only in the presence of a polar molecule. Now this interaction is proportional to, or the forces of attraction are proportional to the r inversely proportional to r power 6. The magnitude of induced dipole moment also depends upon the magnitude of the dipole moment of the permanent dipole molecule, that is here in case of this it is HCl, and the polarizability of neutral molecule. The forces of attractions can depend on the dipole moment of HCl and also the polarizability of the neutral molecule. How well the electron cloud can be deformed in the molecule is nothing but the polarizability. These repulsive forces between the particles are due to electron-electron repulsions and nucleus-nucleus repulsions. So repulsions are always between the like charges. Electrons in every atom or molecule is negative, and nucleus in every atom or molecule is positive. So when the electrons of different atoms come close, they repel. Similarly, nucleus of different atoms come close, they repel. These lead to the repulsive forces. When electron and nucleus of two different atoms come close, now they attract. These are called attractive forces.